In this video, we are going to see how we can improve dramatically the quality of the lighting in Unity. The thing is, Unity uses real-time lighting. What does this mean? This means that by default, all the lights that you see in Unity are being rendered as you see them. This has some advantages. For instance, I can rotate the light, and when I rotate the light, the shadows rotate accordingly. But it also has several limitations, because if you calculate the lights in real time, it slows down the computer and it has several problems and limitations. The first problem is that the quality of the lighting is not as good as the one that you would get in a regular rendering. For instance, in this case, the exterior of the house looks pretty good, but if I go to the interior of the house, you will see that the surfaces, they look very synthetic, they look flat. In this case, for instance, in this wall, you see that there is no shadow behind the TV, for instance, and the color of the wall in general is completely flat, which is something that never happens in real life, because in real life we have the bounces of the light, the indirect light that propagates through the scene and creates some natural shadows and lights in the inside. This is one problem, but there's another big problem. For instance, let's say that we want to illuminate these drawings, these pictures here. We can create a new light. Let's create, for instance, a spotlight. You see this spotlight here. We can move it around so we can use it to illuminate the drawing. And we can change the angle so it lights more. As a matter of fact, I'm going to do something. I'm going to set up a higher spot angle for this light, and here we have the range. We can change the distance that this light will light. Let's set it as at 10. I think it was correct as it was before. And now we can use this light to illuminate the painting. But the problem is, Unity can only render so many lights with high quality. If I set up, for instance, the shadows to make it look better, and now I duplicate this light and move it here, you will see. Let's set up this light here. Let's click on Ctrl D to duplicate this light, and now here you can see that we have two lights. But notice that if I create a third light and a fourth light, now we have a problem. Unity is only capable of rendering so many lights at the same time with high quality. Notice that when I have added a fifth light, we have the directional light and 4 spotlights. In order to render these lights properly, Unity stops rendering this one properly. If I zoom in, probably I will see this light turn better, or not. But the problem here, as you can see, is that Unity can only render a limited number of lights with good quality at the same time. If now I erase this light, this will return to being good looking. Okay, so now if I set up lights for all the pictures in the building, in the scene, you will see that we can only see a few of them with good quality. So, as you can see, real-time lights have an important advantage, which is that we can move them and configure them and change them in real time. And also we could even animate them. If we wanted to, we could make the sun move around the sky, and these lights we could dim them and make them change their brightness, etc. but these lights they are limited. The quality, the graphical quality is not very good, and we can only have so many of these lights working properly at the same time. If now I hit play and I move around this house, you will see that as I come closer to the lights, they turn on and off, or more properly, they switch from being badly rendered to properly rendered, which is not, it's not quite bad, but it's not ideal. You see here, these lights are not looking good. So, how can we improve this? What we can do is to turn all the lighting into a texture. This is a great technique for architectural visualizations, because when we turn all the lighting into a texture, this has two very important advantages. First of all, if you turn all the lighting into a texture, Unity doesn't need to calculate the lights in real time anymore. So this means that the simulation will be faster. And second of all, since we can take some time to render the lighting in proper quality, the quality will be a lot better. So this is great because we have better quality and at the same time we have better performance. It has a problem though. Once we have calculated the lighting, we cannot change the lights anymore. We cannot move around the lights, or we cannot change them unless we calculate the lighting again. So let's see how we can do this. And before we get started, there are several things that I need to tell you. This lighting calculation is a very intensive process. It will take some time. Depending on the quality that you set, it can take from minutes to hours. So it's important that you make sure that the rendering of the light that you are going to do works properly. The first thing that we are going to do is to select all these spotlights and turn them into a group. Let's create an empty game object. Let's put it at the 0, 0, 0 coordinate, as I always advise you. And let's change the name to interior lights. Okay. Now, in order to turn the lighting into a texture, we need to do several things. The first thing that we are going to need to do is to again go to my house FBX file, and we need to prepare this 3D model to accept the lighting as a texture. This is an option that we have in the FBX file here at the end, and it's called Generate Lightmap UVs. Click on this option, Generate Lightmap UVs, and click on Apply. This will generate a special kind of texture coordinates ready for receiving the lighting. So now what we are going to do, we have the Generate Lightmap UVs option on. Now the next thing is to select the house and click on Static. This will make the object become static. This is a property that tells Unity that we are not going to move this object once the lighting is calculated. So it will include this object in the lighting calculations. And we need to do this also for the lights. In the case of the directional light, you will see that it has this mode set to baked. Let's check that the spotlights have the same property as well. As you can see, they don't. They have the mode set to real time, so let's change it to baked as well. Okay? Now we are ready to start with the lighting calculations. Let's go to Window, Rendering, Lighting Settings. And this will open a new menu where we can set up the lighting calculations. A couple of things. The skybox material, this is the material for the skybox that we are seeing here. You can change it, but usually you are going to leave the default skybox, and you need to set up which light will act as the sun. In this case is this directional light. If it wasn't, we can drag it again here. Okay. Then we have this environment lighting option, which is the default color for the ambient light. We can leave it as it is. If you prefer, we could set up a brighter ambient color to make all the scene look brighter, but in this case I think it's good as it was. Okay. And now we have two options here: real-time lighting and mixed lighting. The option that we are going to use commonly is mixed lighting. Let's activate this, and with this we are going to activate the turning of the lighting into textures. Now we are going to set all the properties for our rendering of the light in the light mapping settings part of the lighting window. And the first thing that you will notice is that we have an option called Light Mapper. We have two light mappers available, in lighting and progressive. In lighting, commonly has better quality, but it's lower. In this case we are going to use progressive. Okay, and progressive, not only it's faster to calculate, but also it gives a very good quality if you give it enough time, and it calculates changes in real time, so you can see how it's going to look as you go. So it's better to use progressive. Okay. Now, as for the settings, you can leave these settings as they are. These are quality settings that we are not going to touch, but there's a setting that it's very important to set up, and it's the light map resolution. This light map resolution is, as the name implies, the resolution for our light maps, for the textures that we are going to generate to simulate the lighting. And what does this number mean? This means that for each unit in Unity we will have 50 pixels, 50 texture pixels. This means that, for instance, if we have 1 meter per 1 meter here, we would have a resolution of 50 pixels by 50 pixels. This is commonly for shadows and for lighting calculations. This is a good quality. We can set it higher, but it's not very common. We could set it at 100 if we wanted a very high quality lighting, but usually 50 is good enough. But for us to check if the lighting calculation is right, what we are going to do is lower this resolution. This is the same as a rendering in 3D Studio Max or any other program. If you set a lower resolution, it will render a lot faster. So if I set a 5 resolution instead of 50, it will render 25 times faster. So for checking if this is correct, this is a good idea. So let's click on Generate Lighting, and you will see that now it takes a little bit of time, and now you will see that the program is calculating the light for this scene. The first thing that you are going to notice is that the shadows, they become a little bit blurry. They become with less resolution. This is to be expected because we have set a very low resolution. But as even if the resolution of the shadows is not very high, you will already notice that the quality, especially in the interior, is a lot better than it was before. Let's check this wall here that we had problems with before. You will see that here the quality is not perfect because the resolution is low, but here you can already see there are some shadows here that look a lot better. And as for the spotlights, you will see that now, even if the resolution is low, we have all the spotlights properly rendered and visualized. Okay, so this improves a lot the quality of the lighting, but this is not the only advantage. The other advantage is that, as I was saying before, you can turn off these lights and the simulation will go without the lights being calculated in real time. So this is very good because it improves the performance. It makes the program, the application that we create, go a lot faster with bigger quality. The quality is not good enough. Let's turn on the lights again. So what we are going to do now is to calculate the lighting with a higher resolution. Let's not go to 50 because 50 is too much, but let's set it at 25. If I had enough time, if for instance I could go to sleep and leave the computer rendering, you could go to 50 light map resolution or even 100. So the general idea here is that you set a low resolution for starters. I recommend a resolution of 5 pixels per unit, and as you want the quality to improve, you can set a higher resolution, and then you will need to wait more time, but it will improve a lot the quality and the resolution. But even with a resolution of 5, you can check if the intensity of the lights is correct, if the general feel of the lighting is right, and if the quality of the light reflections and so on is good enough. Okay, a few minutes have passed and now we have calculated the lighting properly with high resolution, and as you see, this looks a lot better. We can see these indirect shadows in the interiors, and this looks pretty good. Of course, there are things that we could improve. Maybe it would be a good idea to increase the ambient color to make the indirect light a little bit brighter, but these are things that we can change and tweak and improve. The important thing now is that, as I was saying before, we can turn off the lights, and now we can see our simulation of the house. Let's close the lighting window since we are not going to need it anymore. And now we have finished the presentation. The only thing that we need to do now is to create an application for this project. Let's turn this into an exe file. Let's go to Build Settings, and let's deactivate this option here, this sample scene option. As a matter of fact, what I'm going to do is to delete this sample scene. If you want, you can add this house scene, the scene that we are working on, but by default I prefer to leave this empty, and Unity will simply create an application from the scene that is open right now. So this is simpler, okay? Let's create a PC application. In this case, we are going to create a Windows application and click on Build. Now, very important, please do not save the application in the same folder that you are working in the Unity project. I always create a Builds folder, and inside of this Builds folder, let's create a new House Visualization folder and save the project here. Let's click on Select Folder, and this will create an exe file, an application that we can share with anyone. We can unzip it into any computer. You don't need Unity installed to see this visualization that we have created. Of course, you can create an application for several platforms: Android, iOS, even gaming consoles, but we are not going to do this by now. Okay, this is the reason that I told you not to create your application inside of the Unity Assets folder, because it creates a lot of separate files and folders. All these folders, you need to keep them together. When you are going to deliver this application, it's important that you select all the files and zip them into a file, and this is what you should deliver as your final application. Now, if I double click on the exe file, Unity, it creates this application with this menu that you can select the resolution, hit on play, and now you are going to see the project that we have created. And as before, we can rotate around the house and we can move around, but the important thing here is that this is a standalone application. Now this is independent of Unity and you can install it on any computer. And if you click on quit, we will exit the application. And with this, we have gone from a 3D model to a complete virtual reality visualization, complete with materials and lighting calculations.